Welcome to the demonstration of interleaved Buck Cascaded Buck Boost converter for AC induction motor speed controlling. So here we are going to develop the Buck Boost converter, and that is driven by the PIC microcontroller based on the input signal from our SMPS. So in this version we are using a SMPS instead of battery. So directly the SMPS will provide us a 12 volts 20 amps output by taking the 230 volts AC input. So another power supply is for our PIC microcontroller motherboard, that is from this adapter we are providing 5 volts outputs, and the two it will read the input from the one is after this buck boost converter and before the buck boost converter, nothing but the input and output. So that will be displayed on the LCD screen along with, so if the voltage of the input is above around 12.5 13 volts, then it will go with the buck mode, and whenever is the voltage is above 8 volts and below 12 volts, then it will enter into the boost mode to boost up the voltage till 12 volts to make the motor run continuously with help of this H-bridge inverter. On this H-bridge inverter we are making use of CD4047 IC, which will act as a dual timer and which will provide the 50 Hz clock frequency. So that pulse is given to the two MOSFETs. So these two MOSFETs will act as a switch between this 12 volts 20 amps DC power supply and step up transformer. So here we are going to convert the DC to AC from this circuit. So that AC 12 volts given as input to our step up transformer. So we need to connect this 3 pin over here. So now the transformer will step up the 12 volts AC to 230 volts AC and directly given to our AC motor. So here whenever we set the voltage, so for setting the input voltage we need to rotate the pots on this SMPS. So there we can see one small pot. So this is a small pot is there, right? So this is a small pot. We need to rotate in anti-clockwise so that we will get the voltage minimum of 8. When it is clockwise rotation, maximum of 14 volts we will get from this SMPS. So whenever the voltage was compared with help of voltage sensors which we placed here, so these two are the potential divider circuits which will take maximum 50 volts 50 volts DC input and provide us a 5 volts output. So that is a 10:1 ratio. So we are going to make a programming inside the PIC microcontroller to convert that ratio to the actual input voltage. So that is continuously monitored from the A0 A1 pin. A0 for the input, A1 for the output voltage. And we are going to display the so-called status on the LCD screen, which is connected at pin number B2 to pin number B7. And next we are going to control the MOSFETs from the C2 pin of this PIC 60F72, as it's a CCP pin, and it will generate the PWM signal to this MOSFET directly on this one. So including this transformer. So here we are using this transformer as an inductor. So that's why we disconnect the primary and we are using a secondary coil as an inductor on this buck boost converter, and the output of this buck boost converter given as input to this inverter H-bridge inverter circuit, and after this to the step up transformer to the motor. So whenever the voltage was above 8 volts and below 12.5, then it will enter into the boost mode to boost up that to make the motor run continuously without any interrupt. So let us see the demonstration. So first the power supply for our motherboard. There we can see the welcome message, and after that 0 0 because we didn't on the SMPS. So input is 0, output is 0. So there is a light indication on the SMPS also. So the input was 8.7 sets, and this is on off switch for the inverter. So 8.3. So I am changing the input voltage, means I am decreasing that. Sorry, increasing the voltage. can observe the bit fluctuations while we are switching from the boost to buck, buck to boost. That is called the dead zone in any buck boost converter. So now it is in buck mode. So it's a maximum voltage. So let us go with the minimum voltage. Right. So here on this inverter circuit we can see one pot. We already set the pot for 50 Hz of frequency. So that 50 Hz frequency set by this RLC circuits to this CD4047 IC. So that continuously will generate the 50 Hz clock pulses, and that was given through these resistors to the gate of these two MOSFETs. So here using IRF Z44 MOSFETs can handle up to 20 amps of current by this same MOSFET also. So here I forgot to tell about this one. This will combination of our buck boost converter. So this is the high rated MOSFET to can handle up to in the buck mode. So while we are running the system in buck mode, we need to handle the currents with heavy with heavy switching circuitry. So that's why we replace it separately.